Hi, welcome to this trigonometry revision video on trigonometric ratios. We're going to have a look at a couple of key examples in this video. Okay, in this triangle below it asks us to find the exact ratios of sine theta, cos theta and tan theta. We've only got two sides of the triangle, so I think we're going to need to find that hypotenuse. I think you'll be able to think of Pythagoras as the method for that, so we'll put an X there and just find that other side there because we need that for some of those ratios. Just the basic Pythagoras arrangement there of x squared equals 7 squared plus 6 squared because we're finding a hypotenuse there. And processing that, 7 squared is 49, 6 squared is 36. Add those together, x squared is going to be 85. So if we square root both sides, we get x equals root 85, or plus or minus root 85. But in this case, we're looking for a length, so it's going to be positive anyway. Okay, so we've found that hypotenuse as root 85, so we've got all three sides there, so we should be able to piece together sine theta, cos theta, and tan theta from that. Now sine theta is opposite over hypotenuse, so in this case we've got from the angle here, this is our opposite, this is our hypotenuse, and this is our adjacent. So sine theta is 6 over root 85. Now we don't usually leave the bottom of any fraction as an irrational number, so we could actually rationalize that from our surd studies and multiply 6 over root 85 by root 85 on root 85 and just get a rational denominator for that fraction. So we end up with 6 root 85 over 85. So that's just a bit of housekeeping there to get the denominator or the bottom of the fraction to be a rational number. Okay, cos theta is next. Cos is adjacent over hypotenuse, and in this case it'll be 7 over root 85. This, that's a reminder, this is our adjacent side, going from this angle that is, and this is our hypotenuse. And once again we've got an irrational number there, so we'll just cut to the chase there. We kind of followed the pattern previously, so it'll end up being 7 root 85 on 85. We had a look at the outcome of sine theta and just copied that a little bit. We can go a bit faster there. And tan theta didn't need the root 85 in it, thank heavens. And so tan theta is just opposite over adjacent, and in this case is just 6 over 7. We could leave it like that. Now they didn't ask us to find the actual theta. They just wanted the ratio of sine theta, cos theta, and tan theta up here. This is a key word, a key phrase here, exact ratios. So that means we'll leave it as square roots and not put it into our calculator and get any decimals that we might round off later. That's why we wanted to leave our hypotenuse that we found in surd form. So that exact ratios needs to be taken notice of there. Okay, cos theta equals 5 over 8, so we know one of the ratios there, and they want us to find the value of tan theta and sine theta correct to 2 decimal places, so we won't leave things in exact form this time. But there's not much information to go on there. Cos theta is 5 over 8, but we do know that cos is made up of adjacent over hypotenuse, so we actually know two sides of that triangle, so we could draw the little sketch there of that triangle. So we could draw a sketch where you've got theta, you've got on the adjacent side a 5 and an 8 on the hypotenuse side, and that sums up the information so far. Then we could use Pythagoras to find this shorter side. It will involve a minus between all the squared numbers for this type of Pythagoras because we're finding a shorter side, but we can certainly find that shorter side down the bottom there, the x. So we'll just use Pythagoras to do that. I'll just write that quickly down there. Notice we put a minus in between there. We end up with root 39 there. Now they do want the answers in the end to 2 decimal places, but we can do that later. So we can put our root 39 down on our one of our shorter sides there. So once we've got all three sides, there's nothing stopping us finding all the ratios. Tan theta is opposite over adjacent, so from here, going from this theta, we have an opposite on this side and an adjacent on that side. So it's tan is root 39 on 5. That's fine. And if we type that into our calculator, we'll get that rounded to 2 decimal places. And sine theta. Now sine is opposite over adjacent. opposite over hypotenuse. So we've got our opposite here and our hypotenuse here. So I think you can see it's going to be root 39 on 8 there. And typing that into our calculator, we can round it off to 2 decimal places. So we once again used Pythagoras to find that third side, and then we were able to find the ratios, and then seeing they asked us to find it correct to 2 decimal places, we needed our calculator just to round that off. Now this doesn't look all that helpful. It's got a decimal there, but we can turn a decimal into a fraction, and that will be much more helpful for us, like in the previous example. So 0.6 is actually 6 over 10, is it not? And then we could simplify that down to 3 over 5 as a ratio. 3 over 5 is a simpler fraction. And we have tan. Now tan is made up of opposite and adjacent. So we have two sides of the triangle, even though we didn't know we had that, didn't think we had enough information there. So we can piece together a triangle using that information, find the third side. So we've got an opposite and an adjacent in that arrangement. We have a 3 on the opposite and a 5 on the adjacent. And we can find the hypotenuse using Pythagoras now. There's the Pythagoras result. We have a plus in between because we're finding the hypotenuse. And we have root 34 now. Have a look at the question. It says exact values again, so we're going to resist the temptation to type that into our calculator. We're going to leave it as root 34 there whenever we're quoting these ratios. We're going to piece together now. So sine is from the theta is opposite over hypotenuse, so it's 3 over root 34 in this case. And can you guess what we're doing next? We have an irrational number on the bottom there, so we're going to rationalize the denominator by multiplying by root 34 on root 34. We end up with 3 root 34 on top and 34 on the bottom. So anytime we get a surd or a square root number on the bottom, we probably should rationalize it to get a matching answer to what the markers expect there. Alright, so cos theta is the next bit. Cos is adjacent over hypotenuse. Can you see what it might turn out to be? Yep, good guess, 5 over root 34, and once again we'll rationalize that denominator out there and leave it in that that form. We don't want to round it off or anything like that because it asks for exact values again. Alrighty, so don't be fooled by the decimal, just turn it into a fraction and simplify that fraction if possible, and then lay out your triangle, your right angle triangle in the correct arrangement there. We remembered that tan was opposite, and so on top, and 5 was adjacent, so get the triangle right and the rest of it can do itself, particularly with Pythagoras' help there. Okay, here's a whole bunch of information now. I'm not going to go through it piece by piece here, but one at a time here. You'd have to draw a right angle triangle and put B in the corner of it. You'd have to have another point on the triangle with an A, and that side length would be 7 centimeters, and you'd have to try and find a position and angle of 32 degrees there. You could pause the video and try it for yourself there, but I'll cut to the chase and show you my version. So we have a right angle triangle at B. That takes into account that bit of information. We've got another side A, or another point I guess at A, and that length between A and B is 7 centimeters to process that bit of information. And if we've got a triangle ABC, we'll call the other corner C, and we'll have an angle at C of 32 degrees. So piecing together that carefully, find the side length AC. So we have an angle and an opposite side there, and we're trying to find that AC side length correct to 1 decimal place. So we'll have to think about whether we're going to be using sine, cos, or tan here. So going to be using sine. From this angle we have an opposite and a hypotenuse, and so we'll piece together that. We'll make a trig statement out of that, trigonometric statement. Sine 32 is 7 over AC, fair enough. Now, I'm not sure whether you remember from your studies, but what happens, how do you handle a pronumeral or a missing bit that's on the bottom of a ratio? You might remember that we looked to swap places with the AC and the sine 32 as our next step. So that's what we did. We swapped places between the AC and the sine 32. We can type that into our calculator and round that off to 1 decimal place. Okay, so very slowly and carefully we piece together a triangle with all the information correct, and then we look to use sine, cos or tan. It's a right angle situation, so it's just that SOHCAHTOA right angle triangle trigonometry, nothing fancier than that at the moment. Find the value of x if cos 90 minus x equals sine 70. Alright, there's a rule between cos and sine here, and that is that cos of an angle equals sine of its complement. Now, the complement of an angle is what has to add to it to give the total of 90 degrees. So what we have here is the idea that if that's sine 70, this in the brackets here must equal 20. So we're just using that rule from our textbook. And so we can piece together a little equation there that 90 minus x in the bracket there must equal 20. And then we can just solve that little equation. We could subtract 90 both sides just to show you. That minus belongs to the x, so we'll have to be careful there. So we'll get minus x equals minus 70, and then the minuses can kind of disappear. We divide both sides by minus 1, or multiply both sides by minus 1, or just sort of cancel each of them out there. So 70 degrees must have been the value of x there to make that work. Find the value of y if cot 30 equals tan y. Now there's a relationship between that in your textbook as well, so go back and learn the rule if you need to, but I'm here to say that cot of some angle equals tan of its complement. So we're kind of saying what has to be here to make the complement of 30. And here's a bit of a variation on the sine and the cosine bit. So sine of an angle equals the cos of its complement there. So if we've got cos 55 on the right hand side, we'd have to have sine 35 to make those the complement of each other. So I think then we'll try and match up here this section here, and they must be equal to each other. So we'll make a little equation out of that section, 3m plus 8 equaling 35. And we'll solve that as if it's just a two-step equation. We will minus 8 both sides, leaving us with 3m equals 27, and we'll divide by 3 both sides, leaving us with m equals 9. So that will make that work properly. And that's a few trigonometric reminders there, one of each type, just to refresh your memory. And if you're not sure of some of those rules, those complement rules, go back and check them in your textbook or ask your local maths teacher. I'm sure they'll be only too willing to help. PeterBlakeMaths.com. Thanks for listening. Catch you next time.